My dear friends, welcome back to Spice. In this session, we will talk about instrumentation, question and answer. In part one, okay, we'll focus on the basics of 4 to 20 milliamps signal, and also we will touch upon a bit on the smart transmitter. Okay, so this is again, I'm posting this at the request of one of our BSpice well-wisher. Okay, so it's more of a question and answer. And also, I would like to take your, permission. I'm not going to, put a lot of words in the slide. I'm going to talk more based on my experience and understanding. Okay. So part one, we'll focus on various parts, actually, small parts, so that you will not get bored. So here in this session, I will limit to only the basics of 420 milliamps and also about the smart transmitter. We are talking, right? Smart. What is smart? Yeah, let us look into it. Okay. So first is 4 to 20 milliamps. Okay, friends. See, basically this is a type of electrical current loop used in control system, right? So this is the most popular form of signal transmission used in modern industrial instrumentation system. Okay, 4 to 20 milliamps DC current signal. Okay, so this is the most popular form of signal transmission. Okay, so this is an analog signal standard, meaning the electric current is used to proportionately represent the measurements or command signals. Okay, friends. Yeah, it can overcome the resistance of the line and, of course, less susceptible to noise, actually. So the main point is here, friends. It provides a live zero signal, where 4 milliamps represent the lowest measurable value and zero current indicates a fault. Here, of course, you know it very well, but yeah, I just want to, what do you call, remind also. Please see here, the live zero, provides a simple means of discriminating between a legitimate zero signal value and a failed signal. Failed signal in the sense, a damaged cable. See, that is why you can have a question, right? Why not 0 to 20? Why only 4? Yeah, that's right. So it could differentiate. It can differentiate between the live zero, okay, and the failed signal. See, if your cable, disconnected or, damaged, what you will get still get zero, right? Yes. So that is why we need to actually, discriminate between the legitimate 0% signal value and the failed signal. So for that means only you have this 4 milliamps, starting with 4 milliamps. Okay. So that is the concept behind this 4 to 20 milliamps. We start. Okay. Let us go into depth actually for them. Typically, friends, 4 milliamps current value represents 0% of the scale and 20 milliamps value represent 100% of the scale, right? So any current value between 4 to 20 milliamps representing the percentage range between 0 to 100%, right? So 4 milliamps, 0%, 8 milliamps, 25%, 12 milliamps, 50%, 16 milliamps, 70%, and 20 milliamps, 100%, right? For example, if we have to calibrate 4 to 20 milliamps for a temperature transmitter for a measurement range of, 50 to 250 degree, for example. So that means it's related to what? 4 related to 50 degree and 20 related to 250 degree, right, friends? And here, you also know, right, there is also 3 to 15 psi. So this 4 to 20 milliamps is not unlike, 3 to 15 psi, that is pounds per square inch. So there it is a pneumatic signal where a varying air pressure signal proportionately represents some process variable. But the funda is both 3 to 15 psi and 4 to 20 milliamps are referred as a live zero because of their ranges begin with a non-zero value. Oh, okay. So again, to recap, this live zero provides a simple means of discriminating between a legitimate 0% signal and a failed signal. If your cable cut also, you will show zero, right? So in order to avoid that, we start with 4 to 20 milliamps, 4 milliamps. Okay, that's it, friends. Okay. Okay, so that's about the 4 to 20 milliamps. I think we have covered enough on this concept, which you know already. Now, I will take you through the very important aspect, the smart. What is smart transmitter? See, nowadays in the digital arena, we have a lot of developments. So we are talking. We need a smart transmitter. The transmitter should be of smart type. All these stories, right? So what is this smart? Basically, friends, SMART actually stands for single, modular, analog, auto-ranging, remote transducer. Very simple. SMART. Single, modular, auto-ranging, remote transducer. So it's basically a type of process variable. Smart type transmitter is a type of process variable instrument that is able to perform function beyond simple measurement. So that is the point. What is this beyond simple measurement? Yes, simple measurement process value, right? You will be getting your process variable. Okay. Apart from that, you can also get diagnostic function, digital communication, different parameters configuration. So all these aspects you can enjoy if you are going for a smart type transmitter. So that is the beauty of smart type. Okay, let us also talk more on this. See, basically, it's an intelligent transmitter that has an analog output and simultaneously provides a digital communication signal based on HOR protocol or foundation field bus or Profibus, any type of field bus. Okay, friends? Right. I'm also going to touch upon the HOR in detail in the next session, okay, on the instrumentation Q&A. Okay, in general, the simply basically it consists of a sensor or an input circuitry and a microprocessor, and it has a memory and a communication block. So this is all constitutes here in this block. Okay, in this transmitter. Okay, so the word multivariable transmitter is also sometimes particularly for a device like smart instrument. Okay, so multivariable in the sense this measures absolute pressure, it measures differential pressure, it measures the process temperature, sometimes they computate mass flow rate. I'm talking about flow and also the volumetric flow rate. That's why the term multivariable smart transmitter. Okay, friends? Right. Okay. As I explained earlier, again, the output of a smart transmitter no longer just the primary process variable, but what? It also includes necessary secondary process variable and also the sensor health, sensor performance, characteristics, calibration information, and of course the real-time diagnostics. Okay, so these are the benefits of from a transmitter, a smart transmitter. Okay. So thereby, what we achieve, all this information is used to improve the process, isn't it? Yes. Improve the process, optimize the performance, of the instrument, and of course, while extending its lifetime, and also maximize the productivity of the personnel also. Okay. So that's the beauty of this. So there are many more beauty in the sense advantages. Smart transmitter consists of microprocessor, right? So that will have a bidirectional communication. Okay, so smart transmitter includes secondary sensor that can measure and compensate for environmental disturbance, temperature compensation, all these. And of course, it has a signal conditioning and it's analog to digital conversion possibility. And smart transmitter consists of multiple sensor and covering measurement ranges and allow automatic selection of the required range. So it also has a self-calibration capability that allows the removal of zero drift and sensitivity of the errors. These are the advantages actually. And of course, it has a self-diagnostic capability and we can plan the maintenance requirements also. So it can adjust for non-linearities and of course give linear output. Smart transmitter provide improved accuracy and reliability. And of course, long-term stability can be improved, right? Yes. And of course, maintenance cost can be reduced. It allows interoperability, becomes possible for selecting vendors of choice. We don't have to, stick to one vendor. So any transmitter, if any vendor make is, what do you call, can be compatible with any system. So that is, it allows the interoperability, okay? And allows remote calibration and rearranging. And another point, friends, this smart, it helps in reduction in managing a number of span transmitter because, one transmitter can be configured to cover any range. So meaning we can, replace the make it possible to replace the transmitter. See, I'm repeating again. One transmitter can be configured to cover any range. So we can replace with any of the transmitters. So that is the point. Spares. You don't have to have each spares actually for each type of ranges. That is a point here. And some transmitters, like a temperature measurement, it has a facility to connect to the redundant sensor. I'm talking about temperature. Okay. Yeah, redundant sensor, which is not possible with the ordinary transmitter. See, for example, if one sensor fails, actually, the other sensor will find the temperature, which improves the plant reliability, right? So those are the things. And also, another important thing, configuration data that was stored under the same tag can be transferred from our host system, DCS, or using a handheld communicator. So that is also possible here. And of course, majority of smart or loop power. So meaning two wire. Okay. So these are the some of the aspects related to smart transmitter, friends. I hope you enjoyed this session. So now we'll limit this to only the 2 points so that you will also not get bored and get carried away. So let us continue in the next session wherein I'll focus on the Hall protocol, and also I'll talk about the pressure transmitter separately, and also I'll talk about the differential pressure question and answer separately. And also one, I think I want to check with you whether is this okay, this method of, only talking with the limit of the presentation is limited, but we talk more so that you can also, have, a lot of, what do you call them? Concepts. Of course, you need to actually listen to this video 1 or 2 times so that you can get it easily, grasp the concept easily. Probably you can, while driving or maybe while walking, so you can just listen to this audios. Okay. So yeah, I'll leave it to you. If it is okay, I'll follow the same funda for all the question and answers, because, I want to share whatever I know. That's a point actually. I don't want to put everything in form of, bullet points and all. So yeah, thank you again for watching, and of course your support. Keep supporting, friends. Your support is very important. Any questions you can write back to me. I'm willing to support. Okay. Thank you. Take care. Bye bye.